Welcome back, Algebra 1, my very favorite class at the co-op. Are you guys ready for an easy lesson? I'm so glad because you get an easy lesson today. It's called Evaluating Algebraic Expressions, and that is something that's very straightforward for you to do. But first, why is it that dogs don't like to travel on airplanes? Because they get jet lag. And what was the other one that I wanted to do? Why don't centipedes play football? Because by the time they get their shoes on, the game is over. So, last video that we did, was writing an orange in honor of UT. Now, frankly, I could not care less if it's UT or Texas A&M, but because there's such a rivalry here in Texas, I have to pick sides, knowing that whichever one I pick, I can antagonize somebody. And what I was doing, last time I said, I'm sorry, I just don't have a maroon marker so that I can write for A&M. So this is the marker that I got for A&M. And you will notice that that really isn't so much maroon, it's more like blood red for all the blood that they lose when they get thumped really good by UT. So it's too bad that my boys are not watching these videos because they would be going, yeah! Because they totally like UT. Evaluating algebraic expressions. We've had something that says simplify. And simplify means, for example, you want to collect like terms. So that's 7x plus 5b. And we have had, what else have we had? Oh, we've had solve. If we have solve, we have x plus 3 is equal to 6. X plus 3 minus 3 is equal to 6 minus 3. X has a value of 3. So we have solved. And if you haven't done these things in my class, you've done them in another class. Now we have another expression, and this says evaluate. The difference here, simplify, you're joining things together that are like. Solving, you have an equal sign or greater than or less than sign where you can come up with an actual value for a variable, and it always includes that some sort of symbol that's indicating there's a relationship. And then you have evaluate. So here, for example number 1, and this is on page 96, example number 1 says evaluate. Eval, and yes, it looks like a U. Evaluate x squared when x is equal to 3. So the only thing that we're being given is x squared. We're not saying that x squared is equal to 9. We're just saying x squared. Now, because x is a variable, it could be anything depending on what we put in. If we put in 10 here, then it's 100. If we put in 7, it's 49. If we put in 15, it's 225. But they're asking us to evaluate or to calculate the numerical value. Isn't that fancy? Calculate the numerical value of the expression. Calculate the numerical value of the expression. Now, technically you can't say solve, because what I said before was when you're solving, you have an equal sign, you have less than, you have greater than, something like that. Here it's just saying if we give you a specific value for your expression, what would result? So, kids and adults who are just learning to work with algebra tend to use evaluate and solve interchangeably. And it's really not, but it's a technicality, and that's really all that they're teaching you in this expression, in this section. So if we're going to evaluate x squared when x is equal to 3, that means we're going to take this value here of x and we're going to substitute. I think I said 6, I'm not sure where 6 came from. We have x squared, we have this value of 3, we're going to substitute it in for x. Whenever you substitute, get in the habit of enclosing in parentheses the value that you're substituting. 3 squared, that's 3 times 3, which is 9. When you evaluate x squared, when x is equal to 3, you have x squared, which is 3 times 3, which is 9. Why did I say make sure that you, when you are substituting, that you enclose that value in parentheses? Well, when x is equal to 3 and when x is equal to a negative 3. Okay, right here we have the value for x squared when x is equal to 3. Right here we're going to have the value for x squared when x is equal to a negative 3. Enclose that entire expression in parentheses, and this is where you actually have, remember, the negative 3 times a negative 3 gives us a positive 9. And I'm sure you all know exactly where I'm going here, because I've used this expression multiple times, this example multiple times in class already. Negative 3 quantity squared is not the same as the opposite of 3 squared. Here we would have the opposite of 3 squared, which is minus 3 times 3, which is a negative 9. If you will be careful to enclose within parentheses, or if you have to use braces or brackets, depending on what big old mess you're substituting in, if you're careful to make sure that you enclose that in parentheses when you're substituting a value into an algebraic expression, you'll be just fine. Because what you do is first you substitute in the value, and then you use the order of operations to come up with your solution. That's why we have a different answer here. This says take the value and use it as a factor twice. This says take the value, use it as a factor twice, and then take the opposite of it. So let's go ahead and do a couple more expressions that we want to evaluate really quickly. And then you can just be so amazed that you have very little practice here, very little necessity for teaching time here. Let's look at example 2, example number 2. And we have evaluate, and I'm just going to put EV, evaluate x plus y plus z squared. You notice there's no equal sign, so we're not solving for these. This is not some unknown value that we have to come up with, because we're being given the values for the variables already. X is 4, y is 9, z is 2. X is 4, y is 9, z is 2. And as I've said, I slash my z's and I slash my 7s so that you can distinguish between them very readily. And I'm going to go back and check and make sure that I wrote this correctly. X plus y plus z squared. X is 4, y is 9, z is 2. Now let's go ahead and substitute these specific values in for the variables. And that's the difference between solving and evaluating. When you're solving, you're actually coming up with the answer. You're coming up with the value for each variable. When you evaluate, you've already been given those values for the variables, and you just have to come up with the total quantity. X is 4, plus y is 9, plus z is 2, and then we want to square that. 4 plus 9 plus 4. The solution to that example is 17. Very straightforward. No negative values for variables. All we're doing is squaring. See, I told you this would be a very easy section to do. Now, let's go ahead and look at example 3. This says evaluate 3a squared minus b plus c cubed when a is 1, b is 4, and c is 3. Take the time, go back and make sure you copied the problem correctly. 3a squared minus b plus c cubed. A is 1, b is 4, c is 3. Use parentheses. 3 times 1 squared minus 4 plus 3 cubed. Use our order of operations where we evaluate exponentials first. You have 3 times 1 minus 4 plus, now be careful here, this is not 3 times 3 is 9. This is 3 used as a factor 3 times. 3 times 3 is 9 times 3 is 27. Remember just a couple of videos ago I said make sure that you go ahead and memorize your first couple of perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, because it's just easy to remember those. Plus 27. 3 times 1 is 3, minus 4 plus 27 gives us a value of 26. No biggie here solving these, provided you know you can multiply and divide and add and subtract, and I know you all can because you're in my class. Next example is example number 4. This says evaluate x squared times y times z squared when x is equal to minus 1/2, y is equal to minus 2, and z is equal to 1/4. Now we're at least getting something that's more algebra than just arithmetic. X squared y z squared, when the letters are bumped right up against each other, it means multiplication. We don't have to have parentheses to indicate multiplication. We don't have to do the raised dot in between it to indicate multiplication. What this means in expanded notation is actually x times y times z. But it's much neater and cleaner and easier actually to just write this as x squared times y times z squared. And now we have a negative fraction given to us. We have a negative whole number, well, a negative integer, rather, and a positive fraction. Now I want to make certain that I have everything correct. X squared y z squared, x is minus 1/2, y is minus 2, z is 1/4. It's very, very easy to lose track of your negative signs. It is so worth the extra time that it takes to go back and verify that you have everything done correctly. So now we're going to substitute everything in. X is a negative 1/2 squared. Y does not need to be written as y, it needs to be written as negative 2. Z is a positive 1/4 squared. We want to take care of our exponentials first. This right here says use -1/2 as a factor twice. And I'm going to go ahead and do this two different ways. So this is not the way that I recommend. I'm just going to call it first way. But this is the more, this is the still working into algebra way. If you still need to do it this way, it's fine. You need to solve it over here the second way pretty quickly. That's very technical, isn't it? First way, second way. This would be -1/2 times -1/2 times -2 times 1/4 times 1/4. All I have done is I've used expanded notation to say that -1/2 squared is -1/2 used twice. 1/4 squared is 1/4 used as a factor twice. Now I have 1, 2, 3, 4, 5 factors in here. -1 can be written as a fraction over 1, can't it? And we can write all of this, you know, when you're multiplying fractions together, you can multiply numerators. 1 times -2 times 1 times 1. You can multiply denominators. -2 times -2 times 1 times 4 times 4. 1 times 1 times -2 times -2. All of this is over. Negative times negative is positive. 4 times 4 is 16 times 4 is 64. 64. This has a common factor of 2, and I think I'm probably out of space here. So I have -1/32. Now, if you're looking at this mess here and saying, oh, it's a mess, I don't want to do it like that, then I have accomplished my goal. Let me show you how you would solve this problem using a more exponential approach, if you will. This is one way. Let me just go ahead and rewrite this. We have -1/2 used as a factor twice, times -2, times 1/4 used as a factor 2 times. When you have a fraction raised to a power, you're going to, and in this case it's when it's squared, you use the numerator is squared and the denominator is squared. The fact that you have a negative factor used twice, negative times negative is positive. So you have -1/2 squared is 1/4. Numerator, -1 times 1, 1 times 1 is 1. 2 times 2 is 4. You have two factors, two negatives, it's positive. Times a -2. 1/4 square, the same principle. 1 times 1 is 1. 4 times 4 is 16. Okay? 1/4 times the -2 times 1, 16. Now I'm going to write our factors in the numerator. -2, 4 times 16. Okay? Do you see that we have a common factor of 2 that we can cancel out here? When we cancel a common factor of 2, we have a 1 left in the numerator. We have a 2 left in the denominator. We still have the negative sign. So we have -1/32. -1/32. That's the same as 1 over a negative 32, which is the same as a negative 1 over 32. This here in the box would be our standard way of writing our expression, negative 1 over 32. But these all have the same value, all have the same meaning because of the division rules with negative numbers. If the fractions are scaring you a little bit, go back to your fraction books that you have at home, look at how to work with fractions on Khan Academy. Ask me to direct you to some materials, but being able to multiply fractions and cancel common factors, that's a part of basic requirements for being able to work in Algebra 1. If you're still it's okay. Just put in the extra practice time that you need to be able to handle the fractions, and your algebra will go much better. And I will see you next time.